So hey guys, welcome back to our video for the next part of vector algebra. Last time when we started the video, we finished until collinear vector. Let's recap all those that we have studied and then move ahead. Vector algebra. Vector algebra can be classified into three categories. First, basics and direction quotients. Second, algebra vectors. And third, collinearity and coplanarity. We started the first part about vector algebra, which is basics of vector algebra and direction cosines. Vectors represent one of the most important mathematical systems. Mathematical systems are defined as systems which are used in mathematics to solve. For example, algebra is a mathematical system, geometry is a mathematical system, arithmetic is a mathematical system, statistics is also a mathematical system. As all of that, vector is also a mathematical system. Now you understand. In common sense, I am saying that mathematical branch. Vector is also a mathematical branch as algebra, geometry, or even arithmetic as them. Now, why do we need them? In physics, there are so many quantities, so we say they are physical quantity, and they are classified into two categories based on direction: scalar and vector. Quantities which have only magnitude are scalar quantities, and quantities which have magnitude as well as direction are called vector quantities. This is the biggest difference between scalar quantities and vector quantities. For example, distance. Distance doesn't have direction, it only has magnitude. For example, if I say 5 kilometers, you just know that the body traveled 5 kilometers, you don't know in what direction. And in vector, for example, displacement, we say 5 kilometers in direction of northwest. Here you have a proper definition where body traveled. Body traveled 5 kilometers, but it traveled in the direction of northwest. Let's move ahead. Then we have some exercises that we did. For example, we were given some measures, and we have to classify whether those measures were scalars or vectors. For example, 10 Newton. Newton was a vector quantity. Newton is the SI unit of force. 30 km per hour, it is scalar quantity. A kilometer per hour is used in speed. Coulomb. Coulomb is a scalar quantity because electric charge is scalar, and its SI unit is coulomb. So we can recognize things from their units too. If there is coulomb, it means it is the SI unit of electric charge, and it means it is a scalar quantity. By this way, you can also understand or remember which quantities are which, scalar or vector. Then we learned about representation of vector, in which we understood how to represent a vector on a plane. For example, let's say AB is a vector, then how are we gonna represent it? We represent it as a form of ray. A, which is the initial point, and B, which is the terminal point, or else we can say tip. This is how we represent a vector. In the direction we want to show, we just make the arrow in that direction. For example, if I want to make a direction, if we are given direction southwest, we will make an arrow in southwest. This is the main function of arrow. The head of the arrow indicates the direction, and length of the arrow represents magnitude. Then there were 3 points to memorize. For example, few points to note that magnitude of a vector is always a non-negative real number. Means a vector's magnitude can never be negative, as scalars magnitude also too. A vector's magnitude can either be positive or zero, never negative. In scalar also, a scalar magnitude can either be positive or zero. If we summarize both points from both quantities, we can say magnitude can never be negative. Second point, every vector has three characteristics. Characteristics means identity which you see in every vector: length, support, and sense. Length is the magnitude of vector, how much big that vector is, and then when we measure, we got to know what its magnitude. Then support. Support is supposed to say for a vector which is a part of a much bigger vector. For example, there's a vector running from A to B. We draw two dots C and D and make D the terminal point. There's a vector and a vector. Means CD vector is a part of AB vector, but CD vector is also an individual vector on its own. That's what we call support. In sense, CD vector and AB vector have same sense of direction. They don't have different sense of direction. It means they're both same. Then we have few exercises like this, which we are given two questions and we have to plot those on graph. For example, there was a question: a displacement of 60 km 40 degree east of north. So we just 40 degree calculated from the base and plotted a line from its scale 60 km. We can't draw 60 km on a notebook, so we just drew like this. And then there was another question saying like that 50 kilometers southeast, which we drew here. Then the interesting part of the chapter starts, which is called type of vector. We learn four type of vectors: zero vector, unit vector, like and unlike vector, and collinear vector, which you also can say parallel vector. So zero vector are those vectors whose magnitude is zero. How can you represent them? They are not represented by anything, they are just zero. Then comes unit vector. Unit vector are those vectors which magnitude is unity. By meaning, when I say unity is 1, it means its magnitude is 1. It's one of the important vector, not right now in this chapter, but when we move ahead in physics for kinematics, we will use unit vector more oftenly, because unit vector can be used as an SI unit. Just like we use Newton as an SI unit for force, Kelvin as an SI unit for temperature, meter for distance or whatever, unit vector can also be used as a unit. It's in its name, unit. A unit. Its had its own representation. Unlike other vectors, when we write a vector AB and a ray on it, we can write a unit vector with a cap on it, and it's called a cap. It has a very important formula. Vector is equals direction into magnitude. Vector equals direction into magnitude. This is direction, this is vector, and this is magnitude. Representation one of the most important part of the chapter. Then comes like and unlike vector, very easy. Vector are said to be like if they have same sense of direction. When I say like, it doesn't mean it has to be same length. It just needs to be same sense of direction, because if two vectors have same sense of direction, they're like, they're similar. Just because we had learned those three characteristics of vector, length, support, and sense, the third part, sense, is, for example, AB vector and CD vector has same direction. You can see they are all pointing towards somewhere north, east. So they are like vector, but EF is not like to both of them because it has a different sense of direction. That's the proper definition of like and unlike vector. And then comes our fourth vector, which is called collinear vector. Collinear vector is also something like same sense of direction definition. Vectors having the same or parallel supports are called collinear vectors. Means support means length. Now here we are supposing length. One thing I want to say, that vectors on a plane can be moved from here to there. Their position doesn't matter. For example, AB vector and EF vector, these two vectors are collinear to each other. How they are collinear to each other? Because they have same support. Same support means same support means they have same length. Let me clarify again. AB vector is similar to EF vector and GF has also same support as EF, and EF is also something like what parallel support. Support means same sense or whatever that is. We are not saying that their magnitude must be equal. We are saying that at least they have same sense of support. Same sense of support means some time in direction. Yeah. Let's move ahead for our next vectors. And today I'm thinking that I'm gonna finish all less and less more of today. Let's go ahead. The types of vector are very important to learn because when we jump into exercises, we must memorize what type of vector it is. We will write what type of vector it is was. Maybe the questions or even equations or even complex tricky questions won't ask you what type of vector is, but it must be necessary, it must be important for you to memorize all these vectors, to recognize any vector at any point of time if you know. Then comes a fixed vector which is called co-initial vector. Co-initial vector, by its name we can understand that there is supposed to be more than a vector which has same initial point, because in name of the co-initial vector there is initial, so we can understand vectors having same initial points are co-initial vectors. I know I had wrote the name of co-initial wrong, but for now, just compromise please for me, because now there's no space here to write another E between M and T, and if I do so, it will be missed. This is co-initial vectors. I don't even need to see definition because it's very simple. Vectors having the same initial point are called co-initial vectors. This time I'll write spelling co-initial vector. This is a point. From this point there can be more than a vector starting from. See, this is A, this is B, this is C, this is AB vector, AC vector, AD vector has same initial point A. Very easy, isn't it? Then comes coplanar vector. Same as from its name we can understand. Vectors which are on the same plane are coplanar vector. The plane means there are more than type of plane. Not that flat one you know in maths. There is two-dimensional plane which is precise noted. There is three-dimensional plane that we live in world. Our universe is a 3D place. So it is a three-dimensional place. Most often we will keep on to 3D because after 3D we still don't know what to say. So coplanar vectors are those vectors which are in the same plane. If I'm saying coplanar vector, these all vectors that I have drawn in my notebook are all coplanar because they are all in the same plane. If any of those vectors is standing like this, they are in three-dimensional space. They are not coplanar because they have no same plane. One is in 2D and another one is in 3D. Coplanar pin drop silence. When I'm writing like this, everything goes silent. It's like everyone is waiting. Just anyhow. Isn't it? Yes, is it? Coplanar and vectors on same plane. Or even they are parallel to the same plane. Let's write this one. Vectors. When I was saying about coplanar vector, I was saying vectors lying on same plane. Yeah, it's true. Another definition of this is vectors which are parallel to the same plane vector. I mean, if there's a vector in second dimensional space and another vector is there in third dimensional space, they are now coplanar, but they become coplanar when this vector also become parallel to this vector. I already said that position doesn't matter in vector. You can bring this one to the same plane. You're already in the same plane, like this or like this, isn't it? So vectors lying in same plane or their supports are parallel to the same plane they are called coplanar vector. There was a proper image for this one. This is a plane. If you see clearly, there is a vector line here for AB and CD. They both are coplanar because they lie on the same plane, but another vector named EF is not on the same plane but is parallel to both of them. Thus, it's also coplanar because it is parallel and it can be brought to the same plane. Position doesn't matter in vector. So, we learned about coplanar vector. Let's move ahead to coterminous vector. You can see the condition of my notebook using a marker only. No problem, guys. I can continue on this one too. Then comes coterminous vector. As we learned about co-initial vectors, now we are learning about coterminous vector. It means vector having same terminus point or same depth are coterminous vectors. Isn't it? Coterminous we wrote about coterminous vector. Vectors having same terminal point are coterminous vector. Vectors having same terminal points are called coterminous vectors. Simple. I will draw a picture of that too. For example, this is a vector AB, and this is a vector CD. They both have same terminal point, thus it's a coterminal vector. Terminus. Then comes a negative vector. Negative vector. Vector which have the same magnitude but in the opposite direction. It means it is a negative vector. This can be said in two vectors. A negative vector, negative of a vector. Say what? Negative negative of a vector. Negative of a vector. Sometimes silence is much important, much peaceful. Hearing only natural sound. Yeah, negative of a vector. Negative of a vector. what does negative of a vector mean? Let's see. The vector which has same magnitude as the given vector but are opposite direction in 180 degrees opposite direction. The vector which has same magnitude as given vector but a opposite direction. You understand what I'm saying? But a opposite direction. For example, this is a vector x, y. This is a vector 2 and they have same magnitude mn, but mn is negative of xy because it has opposite sense of direction. This is what we call a negative vector. Then comes reciprocal of a vector. A new different species of vector are arising nowadays, which I'm quite surprised. Negative of a vector, reciprocal of a vector, more of them. After all this, we will come into mathematical part. We will derive formulas, understand formulas, what they are saying, exercises, and more of those. It will be very fun to do this. Very fun. So here we go. There goes negative reciprocal of a vector. Reci you cannot see this out after highlighting the reciprocal reciprocal vector. We are gonna highlight this one so that it can carve out from the darkness. reciprocal vector. So what does one say? A vector having the same direction as that of a given vector but magnitude equal to reciprocal of given vector. That's a supposition. For example, what this one is saying, a vector having the same direction, okay, having same direction as that of a given vector, but its magnitude is reciprocal of the given vector. But magnitude is reciprocal of the given vector. Let's say AB is a vector of magnitude x, BCD is a vector 2 with magnitude 1 by x. You understand? Yeah. This is reciprocal vector. For example, let's say this is 2, magnitude is 2 centimeter, then reciprocal of 2 is 0.5. So it's suppose CD has magnitude of 0.5. Reciprocal of a vector means there are two vectors, maybe more than two vectors. They have same sense of direction. They both have same sense of direction, but their magnitude, one of its magnitude is reciprocal to the other. That's what reciprocal of a vector means. Then moving ahead, there are 3 more left: localized vector, free vectors, and equality of vectors. Say localized vector. Localized vector. What does this mean? Let's say localized vector. localized vector. Localized vector, yes. So a vector which is drawn parallel to a given vector through a specific point in space is called localized vector. Very easy definition. A vector which is drawn parallel to a given vector through a specific point in space is called localized vector. Through a specific point in space is called a localized vector. So this is what localized vector means. For example, let's say this one is our given vector AB. AB is our given vector. And let's say there is a point named P. Through this point a vector passes such like that it's parallel to the vector AB. This is what called a localized vector in a very simple way. Then comes free vector. Free vector means this vector can anywhere in the space. They are not dependent on nothing, only accepting length and direction, and is independent of position in space. This is what free vector means. So we don't need to draw. We can draw anything, any magnitude, any position. But if magnitude and direction is given, then you have to draw in that direction. But in any space. What do you mean? Let me say. Free vectors. In this vector, suppose you were given a detail of a vector 5 centimeter 30 degree to the main axis or x-axis. So when this is given, let's leave that. Let's say you are given a vector in magnitude 5 centimeter in northwest direction. In which plane you're gonna point that out? So you are free to choose in any plane. You can write that northwest in 2-dimensional. You can write that in 3-dimensional, and even more. This is what free vector means. Understood? Understood. Free vector. what does free vector say? Let's see. The value of vector depends only on magnitude and direction, but independent of any position in space. Free vector means normal vector in any position of space. So I don't need to draw anything because I had already taught you that what does free vector mean. But the next one, equality of vectors, yeah, it's more of a property than a type. Let's see what this one says, and I'll also say a prominent color for this, which is black. Equality of vectors equality of vectors. Equality of vectors So what does equality of vectors mean? Two vectors A and B are said to be equal only if their magnitude is equal, they have same or parallel support, they have same sense of direction. Let's say there two vectors can be said equal when first point, their length is equal, their support is parallel or collinear, no problem on that. Third, they have same sense of direction. What do I mean by this? For example, let's say this is a AB vector. Its equal vector must have same length. Their support is equal. See, they are parallel to each other, and they must have same direction. Thus, AB vector equals CD vector. But AB vector, let's say this is Mn. AB vector is not equals Mn vector. Understood? And another like this. AB vector is not equals xy vector, because neither they do not have what same sense of direction. This is what I mean here. Even a small vector, because magnitude is not equal to it, it's not equal. For equality vector, there are three conditions. The magnitude must be equal, they must have a collinear or parallel support, and they must have same sense of direction. This is the criteria of being equal vectors. So these were all 12 vectors that we were needed to learn. Here you can see I had wrote every one of them in deep. Zero vector, unit vector, line vector, collinear vector or parallel vector, coordination vector, coplanar vector, coterminal vector, negative of a vector, reciprocal of a vector, then localized vector, then free vector, and then equality of vector. Moving ahead, there is an exercise, more of exercise I would say. Let's say what the question is. Question is like this. There is a figure given. In the following figure, which of the vectors are, first is collinear, second is equal, third is coinitial, and fourth is collinear but not equal. Let's see what our figure is. So our figure is something like this. I'll make it here. There you go. It is C, it is D, it is B vector, and this is A vector. So let's first see collinear vector. collinear vector, you understand it must have same support or parallel support. Let's see which have same support or parallel support. For first, does A have any collinear vector? A, C and D, isn't it? A, C and D are co-linear vector because A and C has same support. When it brought, it is collinear, and D also brought to A, it is collinear. Equal vector. So which one of those equal vector? I think this is A and C because they have same magnitude, then they have same support, and then they have same sense of direction. So A and C are equal vectors. Then the third part is which is co-initial vector. So B, C and D are all co-initial vectors. And then comes our fourth part, collinear but not equal to an A and D are collinear but not equal because they don't have same sense of direction. D has opposite sense of direction. More often we can say it's a negative of A, which we learn that negative of vector which having same magnitude but opposite direction. There we go. Our types of vector is finished. There were 12 types of vector: zero vector, or you can say null vector, unit vector, then like and unlike vector, then co-linear or you can say parallel vector, then there was co-planar vector, then co-initial vector, then co-terminus vector, then negative of a vector, then reciprocal of a vector, then localized vector, then free vector, and last but not least, and it is equality of a vector, which taught us the criteria of how vectors can be said equal. So for now, thanks for watching. Please like and subscribe the video. If you don't like it, don't like. If you do want to dislike, do dislike. But if you're watching, I'm very thankful to you that someone is at least watching this video, because I know it's going for new views. But still, this is my passion, and I'll keep continuing this. So I hope you have a good day. Thanks.